So in the last video, I told you that there are a lot of improvements to be made to this code. If you haven't seen the last video, you can click there. Let's look at what those improvements are. First, whenever we open a channel, like fetch events here returns a channel of events. Whenever we create a channel, we have to close it. We can't close it here because we would return a channel that's being closed. And then every time that this ticking function tries to push something to a closed channel, it'll panic. So we can put this close event in the Go routine. We put it here, okay? And the same thing happens in this notify event starting. We're creating an event starting channel that will emit every time an event is about to start. We have to put it, remember that, just to recap a little bit of what we saw in the last video, notify event starting receives a channel of events. So we just pump events into this function and we iterate over these events that are coming in and we set alarm. And then we return a channel that emits every time an event is about to start. So we want to close that channel and we can use the defer keyword here to say, hey, execute whatever I'm going to pass to you at the end. Close event starting. So how's this going to work? When you are done iterating over the events, which means that this channel has been closed, so you break out of the for loop. You come in here, when you're returning, you're gonna execute close event starting. All right, so the next thing that we have to look at is cancellation. How do you cancel an alarm if an event is canceled? So let's talk a little bit about the Go context package. Basically, context is a package in Go which allows your function to receive some sort of context information and to be aware of things like, hey, the parent's being canceled. So imagine that you have a task, right, that has a parent context. And from that task, you spawn a lot of little children tasks. You want to propagate cancellation so that if the parent is canceled, all your children will be canceled as well. And that's kind of what we want here. So to show you what that would look like, let's say that I receive a context here, which is going to be a context. Now, in order to create a cancelable child from this context, you can say this is a child context 1 with cancel function 1. And then you say context with cancel, and then you pass in the parent. And let's say, just to illustrate, we do this multiple times. Or what you could do is, for instance, you could create a parent with a cancel and then context with cancel. So you receive a context. From this context, you create a child, which is going to be the parent for this function. And then you pass that parent here. Like this is your grandparent. Now you have your parent context that you can cancel and you have all your children. So if you cancel the parent, if you call cancel, remember this cancel function is to cancel the parent, all of these children will be canceled too. So I can do that for every alarm. Every alarm can be a child. And when you cancel the parent, it'll automatically cancel all the alarms. How do we know that a child context is canceled? Well, we can say child context 1 dot error equals context canceled. When one of these is canceled, it'll start showing the error that's canceled, right? So we can propagate cancellation in this way. I'll show you how it works. So first of all, let's come back here. You remember that in the previous video, we created a timer and then this timer emits a value when it expires, right? So in reality, we can just do something like time.sleep, time until alarm. And this would just sleep. This little mini thread would block here until the alarm. The reason why I did it this way will become clear in a minute. What do we want to do? For each alarm, we want to create a child context of this context that we receive. And we want it to be cancelable context. So we'll say, you know what? Let's call this parent context. So we'll create context and a cancel function is going to be with cancel of the parent context. And that's it. A context can emit a value when it's canceled. So you can say context.done. Just like this timer emits a value when the timer is done, this can emit a value when it's canceled. Really, you need to wait here until either one of these happens. So you care about the first one happening. So there's a way for you to do that in Go, which is called a select operator. So it works like this. You say, let's take this and say case, and then you say case. So this is the select operator. The select operator basically lets you listen on multiple channels at the same time. And when something happens on one of them, it'll trigger your function. So when the timer is done, we want to push the event to event starting. So we push the event here. And when the alarm is canceled, we want to just not do anything, right? Maybe we can print. And actually the thing that we want to do is we want to cancel this timer. We want to stop it to release resources. What do we have now? We have a timer, and we either wait for that timer to expire, in which case we fire the event into the event starting channel, or we just stop the timer because we don't care about it anymore. Now we have to call this function. So in this map here, I have a map of strings to calendar events. In reality, maybe what I want is an event alarm, which is a struct. A struct is like an object in JavaScript, right? So you have an event which is of type calendar event, and you have a cancel, which is of type context cancel func. Now, instead of just mapping to this, I can map to event alarm. Okay, so here I can't just store the event anymore. I actually have to store the event alarm that has the event and that has the cancel function. How do I use this? The same event can be emitted multiple times here because we're polling the calendar. So we retrieve all of the events every 5 minutes. We'll see, for instance, the same meeting multiple times. So that's why we have this. We check if that alarm is already set, meaning if we already have an entry in this dictionary for that event. And if it's set, we continue. But this is the logic that needs to change, right? Because we need to say, if an alarm is set, well, now an alarm for that event has already been set. So what do I need to check? I need to check if the event's been canceled. So I can say if the event status is canceled, then what I want to do, I want to, and we're not reading the value here. We have to actually read the value now. I want to cancel the alarm. Now, what is the other thing that can happen? That the event was moved. So maybe it wasn't canceled, but it was just rescheduled. So you can say if the event dot start, if the start time is different from the one that I had recorded in my alarm, then what do? Well, I want to cancel the alarm first because the event has been shifted. And here, by the way, we need to clear this map. We need to remove the entry. So let's delete the entry, and we also want to delete the entry here. Oh, by the way, and after deleting the event, we also want to just continue, right? Because there's nothing for us to do. These events being canceled. But here we delete this event, but we want to set a new one, right? So we want to continue with this flow down here. Okay, we don't want to stop. We have to set a new alarm for the new time. The last thing is, if the event has not been canceled and the start time hasn't been changed, then there's nothing for us to do. Just leave the alarm as is and it'll fire. This alarm.cancel, remember, is gonna execute this cancel function, which is gonna trigger this case, which is just gonna stop the timer and not do anything, and it's not gonna push anything to event starting. So now we have successfully implemented cancellation on our alarms. What are the things that we still have to do? We are removing things from this map when events are canceled or when they change. But when they fire successfully, here, not really, but here we should delete from event alarms, we should delete the entry from this map because, the event has fired, so we don't care about tracking it here anymore. The problem though is that it's not that simple for many reasons. First, I'll give you the logical reason. So you fire an alarm. What if the event lasts an hour? A whole hour. You see the event again. It's gonna fire the alarm again because it's not gonna find it in this map. So it's not gonna know that it fired. So you should only remove events from here when they finished. So you only fire the alarm once. But the other reason is also that there's a racing condition, right? So this could be executing in parallel with this if you have more than one core and you have it enabled. While this go routine is trying to read this map, this one could at the same time be trying to delete an entry. So you have a racing condition. So you have to use a lock. You have to use a mutex, for instance, or a channel. There are multiple ways, right? But all right. So the one thing we're missing to make this code compile is we added this parameter here, right? The parent context. So we need to pass this in, right? So now we have to pass in a context here. Now we can pass context.todo. This will just pass a context from which all the other contexts can be inherited from. We may want to watch signals or something and then cancel this fetch. We can, you know how I said that this ticker will never finish, therefore this channel will never be closed. We could pass a context here as well, you know, and have this context add a select here as well, so we can cancel this. We're not gonna do that because right now it doesn't make a lot of sense. But now we have cancellation. One last thing I want to show you guys in how to improve this code is that here we could actually be using a little bit of more idiomatic methods, right? So instead of calculating now, here we could say time until event end time. If the time until the event time is less than 0, the event has already ended, right? We could do the same here. We could just calculate the alarm time, and we could say if the time until the alarm time is less than 0, and here we could say the time until the alarm time. Looks a little cleaner, it's a little better. All right, so in this video we saw many things. We saw the select statement for channels, how to cancel, how to propagate cancellations, the fact that you have to close your channels and your files and everything, and the defer state and the defer keyword, which lets you postpone an action until the end of the function. In the next video, we're going to improve on this even further by decoupling the polling logic from the alarms that are fired, which is actually a very interesting idea that I had, and I thought that you're gonna enjoy it. So I'll see you guys in the next one.